Hello, so in today's video, we're going to answer question 6 from the Edexcel 2022 Paper 1 Pure exam from last year. So we're recording this currently in 2023. So this was last year's Paper 1 Edexcel 2022 Pure Maths exam. So we've done the first few questions in some of my previous videos, and we're going to look at question 6 today. So question 6 is about this curve here. So we've got a curve here, figure 1 showing a curve, a sketch of the curve C with the equation y equals f of x. We have this local maximum point here at 2, 8. We've got this local minimum point here at 6, 0, and it passes through the origin, so it's got a root at x equals 0. So we can tell that from the sketch of the graph. So the first question says, write down the set of values of x for which the derivative of f is less than 0. So, okay, so with this one, we've got to look at our curve and we've got to think, okay, so where is the derivative less than 0? So remember, the derivative is essentially the gradient of your curve. So where is the gradient of this curve less than 0? So looking at our graph here, I mean, the gradient at the start here is positive. So it's all positive here up to this point here. So up to an x coordinate of 2 there, the gradient's positive. But then the gradient becomes 0 there, and then it becomes negative. So then the gradient becomes negative until we get to 6 on the x-axis, and then the gradient becomes 0 again, and then it becomes positive. So between 2 and 6, we can see that the gradient is negative. So the gradient is negative. So f dash of x, the derivative of the function, is negative between x equals 2 and x equals 6. So for part A of the question, your solution to that would be x between 6 and 2. So as long as x is between 2 and 6, your gradient is decreasing. Your function, well, your gradient's negative, so your function's decreasing. So that's what that means. So that would be the first part of the question. So then the next part of the question, part B, so the line with the equation y equals k, where k is a constant, intersects C at only one point. Find the set of k values, giving your answer in set notation. Okay, so this curve y equals k is going to intersect this curve at only one point. So we want to find the set of k values. So y equals a constant k. So these y equals graphs, so y equals constant graphs, so y equals constant graphs, these are just horizontal straight lines. So horizontal lines, because it's just coding, it's just telling us that the y coordinate is a constant value. So could be this, could be that, could be this, could be any of those straight lines here. So what we're going to do is we want to identify the lines that give us one solution, so have one point of intersection. So I mean, if we, for example, draw a line like this, well, we get one point of intersection there, don't we? So that could be a possible k value. So this k value here on the y-axis would be a possible k value there. I mean, we could have a k value there, couldn't we? Again, that's going to give us one point of intersection. What happens if we've got a k value like here? Well, now we get 2 points of intersection, so that's not allowed. So we can't have this one. So let's just put a tick by there, cross by there. So it looks like y has got to be bigger than 8. So I mean, in this region here, going up to there, we know that y is greater than 8. So when y equals 8, we actually get two solutions, don't we? We get this point of intersection and that point of intersection. So y equals 8 would be that one. That doesn't work. And then if we go below a little bit, well, now we get actually 3 solutions. So no, that's not going to work either. And then we're going to go down again to the x-axis. So when y equals 0, so remember, this is the y equals 0 line on the x-axis. Again, we've got these 2 points of intersection there. Again, we're not allowed that. We only want 1 point of intersection. So again, if we draw a line below that, so a line like there, now we get 1 point of intersection. So if y is less than 0, so if y is less than 0, then we also get 1 point of intersection. So we're not allowed anything in this region here. Let me try and change the color to a different color just to emphasize. We're not allowed anything in there. That's not allowed. But y bigger than 0, bigger than 8, we're allowed that. y less than 0, we're allowed that, because again, these two sets give us one point of intersection, and that's what we want on the curve. So therefore, find the set of k values giving you which give you one point of intersection. So it's basically going to be k less than 0 or k greater than 8. So if we want to write this in set notation, because the question wants us to do that, so in set notation, we can write it like this. So it's the set, so we can use curly brackets or a set. So it's the set of k values in the real numbers, so the set of real k values such that k is less than 0 and k is greater than, or k is greater than 8. So the union symbol. So either k can be less than 0 or k can be bigger than 8. So it's the set of k values such that k is less than 0 or k is less than 8, and we can use the union symbol there. So again, if we just write this out in a straight line, just to be clear, it's the set of numbers in the real number line such that k is less than 0 union with k bigger than 8, because either k could be less than 0 or, and remember the union symbol means or essentially, k is less than 0 or k could be bigger than 8. So that's going to be our set notation solution. And then part C, to find the equation of C, you may leave your answer in factorized form. Okay, so this one we actually want to find the equation of this curve. And we can use the information here to kind of decipher what that will be. So, I mean, we know it's going to be a cubic. I mean, that's the first thing we can tell with this. In fact, what I'm going to do actually is just rub out these lines because it's kind of confused me a little bit. Yeah, so we know it's going to be a cubic. Let me just rub out these points of intersection here. Definitely going to be a cubic. And we've got two solutions. We've got two roots to the curve. So we've got x equals 0 there, x equals 0, and we've got x equals 6 there. The key thing to note with this root here is that this is a repeated root because it's just touching the x-axis. So this is a repeated root. So remember, I've done a video on this actually in my, I think it'll be in my quadratics playlist or maybe my algebra playlist. I can't actually remember, but I'll link this that video that I'm on about at the end of this video, so you can watch that one. So remember that if you've got a repeated root, that means that the function is going to have a factor. If you've got a repeated root at x equals 6, it means you're going to have a factor of x minus 6 squared in your equation. So what we've got then for our function, so our function is going to be equal to, so we've got this x equals 0 root, so we'll keep that there as x. So we've got x there, and then multiplied by our repeated roots, we've got a root of x equals 6. So the factor, using the factor theorem, x minus 6 must be a factor, therefore x minus 6, and because it's repeated, we got to square it. So remember, it's a repeated root because it just touches the x-axis, it doesn't pass through the curve. Okay, so that's all fine. So you may be wondering, well, maybe that's the function there. We actually have another number, or we will have to check if there's another constant multiplier in front of the function, because there could be another number here. I'll just make a note that this is just some real constant value. Yeah, we've just got to check whether there is another constant. Could be a number 2, could be 3, could be like 5, whatever it may be. So we're just going to check that. To check that, we've got to use the data that we're given up here, that we've got a coordinate of 2 and 8. So we're going to use that piece of data there to help us work out what the a value would be. So we've got so far y equals a times x minus 6 all squared. And now we're going to plug in this coordinate 2 and 8, and that's going to help us work out the a value. So we're going to now sub in, so sub x equals 2, y equals 8. Yeah, and then that's going to give us our coordinates. Well, that's going to help us find the a value. So we're going to get 8 equals a times 2, which is 2a, and then 2 take away 6 all squared. So that gives us 2a, and then times by minus 4 squared. Well, that's going to be 16. So we get a is equal to 2 times 16, which is 32a. And so therefore, that means that a is equal to 8 over 32, which is the same as 1/4. Okay, so what we know then is that the a must be a quarter, and so therefore our graph is going to be y equals a quarter x times x minus 6 all squared. and that's our graph there. So that's the equation of the curve. So it does say in the question, actually, you may leave your answer in factorized form. So you don't have to factorize this. I mean, we can just leave it like that. And in fact, I'm not going to bother factorizing it. We'll just leave it like that because it says we can leave it like that. So that's our graph of that curve there, and that's the end of that question there. So this question is about just getting you to realize, just getting you to identify where the gradient is negative on the curve, on the cubic curve, and also to actually identify the equation of a cubic curve by using your knowledge on repeated roots. So knowing that if x equals 6 is a repeated root, then x minus 6 squared is going to be a factor, because that's how repeated roots work. And obviously you've got the other root there, the simple root is called. So a root which passes through the x-axis, a normal root, is called a simple root, but you don't need to know that for A-level maths. And then you can use the coordinate up there to find this missing constant, which we do need to include because remember, there could be that missing constant, and in fact in this case there was that constant. So we just got to make sure we do scale up our graph to represent all the coordinates that lie on the curve. So yeah, that concludes today's video.